So once again, welcome back to the 7th session of this FDP. We have our resource person, Dr. P. Shanmugavadivu ma'am, who is currently Professor and Head, Department of Computer Science and Applications at Dindigul Rural Institute, Dindigul. She is involved in teaching, research and extension works. She has more than 30 years of academic experience and more than 20 years of research experience. She holds an additional responsibility of a director IQAC at her institute. Her research areas include medical image analysis, healthcare analytics, parallel computing, software engineering, and content-based image retrieval. Under her guidance, 9 PhDs have been awarded, and presently 8 scholars are pursuing their PhD. And she has guided more than 20 MPhil scholars and published 52 research articles in international journals, 86 papers she has presented in international and national conferences, and she has 16 book chapters to her credit. She has also authored 2 research books and 2 edited volumes. Her SCI Science Citation Index is 37, and Google Scholar Citation Index of 535, and H Index 12, and I10 Index 18. She serves as the Board of Study member for various universities and colleges, and also she is an editorial member of 2 journals. She has been sanctioned research projects from different funding agencies like UGC, DST, ICMR, and PMMNMTT for a total outlay of around 2.39 crores. She serves as a coordinator for her department's funding schemes under UGC SAP DRS1 for 40 lakhs and a DST FIST for 45 lakhs. She has been on to international assignments to Singapore, Malaysia, USA, and China, and she has organized a national conference, week-long Digital India programs, and 2 workshops. Also delivered 200 plus talks in various FDPs, national and international conferences and seminars, and organized many workshops on artificial intelligence, machine learning, and deep learning using Python programming. She has attended the MHRD's Leadership for Academicians program called LEAP in 2019, hosted by IIT Bombay, and also she has attended the second leg of LEAP at Nanyang Technological University, Singapore in February-March 2019. Coming to her academics, she holds a BSc Physics degree and a Master's degree in Computer Applications from REC Trichy, the current NIT, and PhD from GRI, Dindigul Research Institute, Rural Institute, on the topic of digital image restoration. Apart from that, she also holds an MBA degree from IGNO on Human Resource Management as specialization, and also MSc Applied Psychology from Bharatiya University, and she is qualified for UGC NET and SLET exam. And the most distinguished notable awards, she is the recipient of Indo-US 21st Century Knowledge Initiative Award 2015 on the title Augmenting the Curriculum of Higher Educational Institutions with an Online Integrated Cognitive-Based Employability Skills Assessment System using Signal and Video Analytics. It is one among the 4 projects sanctioned for in India with a funding outlay of 125 lakhs. With this short note, I once again welcome Dr. P. Shanmugavadivu ma'am, and ma'am, we are glad that you are here for giving your valuable time and disseminate the knowledge to our participants. Thank you once again, ma'am. Over to you. Ma'am, I think you are muted.
Yes. So, warm greetings and pleasant morning greetings to every one of you. And my special greetings to Dr. Chandramouli, who is heading the Department of Computer Science at CUTN. And our association goes probably a decade back.
2004.
Yes, and I'm happy that we have got an opportunity.
2002.
Yes, to get connected to you as well as to CUTN all over again. And first of all, I congratulate the team for having taken up this endeavor during the pandemic, having submitted the proposal and got the approval, and you are conducting this FDP. I think I have to be given the right to share my PPT because that has not been enabled. Yeah, now it has got enabled. So I appreciate the efforts taken by the Department of Computer Science of CUTN to reach out to many faculties across the country, and especially on a very important topic, how you can use machine learning for the latest research work, especially in the light of machine learning and other things. Right? So please permit me to share my PPT. Is it visible to you now?
Not yet, ma'am.
Not it.
Yes, ma'am.
Yeah.
Ma'am, your slides are visible now.
Thank you. Okay, so let me get into the business. And my hello to all the friends at CUTN. And now my topic is classical machine learning algorithms using Python. Now I want to give a kind of small caution, and because there are good number of programming languages available to implement the machine learning and deep learning models, but still this Python programming has an edge over the rest of the tools. So that is the reason why probably the organizers have chosen this as Python. Now I'm going to go deep into the principles and pros and cons of all the machine learning methods. I will just let you know how you have to work with Python, because working with Python with respect to machine learning is a child's play. So let me not go into how you can code and what are the essential parameters available. I'll give an overall idea about the machine learning algorithms and machine learning models, and that will really facilitate you to go further on your own. So this is my roadmap, session coverage, just an overview about artificial intelligence and machine learning introduction, applications of machine learning, types of machine learning models, machine learning using Python. So may I have just a profile of the participants who are available? Can one of the organizers enlighten me on the profile of the participants?
Yes, ma'am.
Please.
There are faculty, there are research scholars, and there are some MSc and MTech students also, very few.
Okay.
Majority
Well,
of them are faculty.
okay. Thank you. Thank you. So let me have a head start before we move into machine learning, and we have to have a mental setup about why should we start learning about the new technologies which are coming up and really haunt us, in fact, right? Before starting to raise new question, new possibilities, to regard old problems from a new angle, that really requires creative imagination and marks a real advance in sciences. So these are the words of Albert Einstein. And that becomes an universal truth statement as we look into the advancements that is happening around us. So the common fact of today are the products of yesterday's research. So there is no end to research and there is no beginning to research. So the research that was done yesterday may be an input for today, and what that we do today may become input for tomorrow's. So there is no stop point, there is no start point. It all depends on what is our perception about research and how we take it forward in the light of innovation and the other aspects that really assure standards of any research. So these are the words of Dalai Lama. He says, developing inner value is much like physical exercise. The more we train our abilities, the stronger they become. The difference is that unlike the body, when it comes to training a mind, there is no limit to how far they can go. So why did I take these words? Because now this involves training the mind of a human being. Now, this machine learning is going to deal about training the mind of a computer. Right now, by writing or by developing machine learning algorithms, we are going to have a kind of mimicking of the functionalities of human brain in the model that you do. So, as there is no limit to train a human brain, the same thing holds very good for training any machine learning model or artificial intelligence model. There is no limit on about how far you can go in training your brain. So this becomes a kind of threat for us because we do not know how far this artificial intelligence is going to proceed and how far it is going to really help us to ascertain on its potential, or is it going to be a big challenge for a human being? Because we talk about incremental learning, we talk about the machine learns by itself beyond the scope of a model. So these are all the kind of threats that we have, but let us not look into it. Let us see how best we can use it for our research. So this Python is a new domain, and when you start working with machine learning algorithms, that is going to give you a kind of an entirely new ecosystem. Probably we may not be comfortable with, or we may not be really aware of what is happening around. But leaving all those things, we are just going to look into the potential of exploring or harnessing the impact of artificial intelligence in the domain of computer science and its allied domains. So I think you all must have heard about this Kaizen principle. This is a Japanese terminology, Kaizen, that speaks about Kai stands for change and Zen stands for good. What is it all about? And may I ask the participant just to visualize. Suppose if you ask you to raise your hands, probably you may raise as you like or as you desire, whether you are very vibrant or whether you are dull, depending upon your mood, probably you may raise your hand as you like. But when there's an instruction, stretch your hand to the fullest potential possible, then you do your best. So this is the kind of change that you have to perceive with respect to when you're given a task to do. You may not do it with 100% commitment, but when there's a kind of inner instruction to guide you, I'm going to do it to the maximum extent possible, the best perfection possible. Probably that is going to give a lot of insight, and that is going to assure successful outcomes or the maximum output. So these are the 10 principles. Throw out all your old fixed ideas and traditional way of doing things. So this is very important when we talk in terms of traditional computing versus artificial intelligence based computing. In the case of traditional computing, our approach is different, our mechanics is different, and the way in which you handle the data is different. But as we talk about artificial intelligence and machine learning models, now there is going to be a paradigm shift. It is going to be radically different from how you have planned and how you have worked. So there is going to be a radical difference with respect to working in machine learning algorithms, for which we should be mentally prepared. So throw out all your old fixed ideas and traditional way on how to do things. So treat others as you want to be treated. This is very important. This is just a kind of personal advice. So do not blame anyone, blame processes or not the individual. So please let us give a kind of confirmation to ourselves. And if it is going to be success, right, we are responsible. And if it is going to be a failure, we are also partially responsible. So let us not blame anything and try to look at the positive side of anything that happens and try to improve our productivity or performance or our positive trait. Being positive, don't say I can't, right? Suppose if there is going to be a proposal on machine learning, right? I mean, call for proposal for funding. Unless otherwise you are conversant, unless otherwise you can show some evidence that you are already working in machine learning, you may not be able to submit a proposal. So think positive that you are going to submit some proposals in the light of artificial intelligence and machine learning. So let this be a starting point to explore the machine learning algorithms, understand their potentials, and then try to apply in your domain wherever machine learning is a viable solution as a programming tool. So think positive, don't say I can't, but because I can't can also be changed into I can at any point of time. So don't wait for perfection. 1% improvement now is fine. Now, after after you attend this FDP, and after you learn the essentials of Python programming, that may not be sufficient for you to shine as a very effective programming personnel in terms of artificial intelligence and machine learning. But we have to ideally hope that the 1% improvement that I'm going to show every day towards machine learning and Python programming may elevate my standard of handling complicated problems and writing complex code. So correct mistakes as soon as they are found, right? Suppose if you come across any setbacks of yourself as you're going to work with machine learning model with regard to less knowledge about machine learning model or less knowledge about the potential of Python programming, all that we have to do is we have to enrich our knowledge about the understanding of all these components and try to see how best you can put everything in place so that it becomes a kind of feasible approach for you for problem solving. So correct mistakes as soon as they are found and don't substitute money for thinking. Now, when you start working with machine learning, what is going to be my monetary benefit? How it is going to help me in other perspectives? Please don't think that way. Now, you all must agree with me, and whoever is in the domain of higher educational uh, arena, not only higher educational arena, now this is ideally applicable for anyone who is in the domain of education. Now, it is like education for life, education through life, and education throughout life. Once you are into the stream of education, right, there is no end for us about learning. So that learning should be a continuous process, and we should always look forward for the opportunities which will enable you to learn something new so that you become a kind of enabled person to handle new technologies. So don't substitute money for thinking, creativity before capital, because creativity is the key factor that really guides us in innovation, that really helps us to take our ideas forward. So for any problem, keep asking why until you get the root cause, right? Just be a good researcher who keeps asking questions and until they reach the point where everything gets clarified, right? And you have to keep questioning unless you get the right answer for the question that you have in your hand. So before the wisdom of 5 people than the expertise, better to use the wisdom of 5 people than the expertise of one. What is this called as? Any one of you? Can you just tell me the term for this? Better the wisdom of 5 people than the expertise of one. What is this called as? What is the noun that you can give for this? Any students who are attending, those who are participating? You call this a synergy, right? So in energy is your own potential, and synergy is you work in a team, because team itself is an acronym that stands for together everyone achieves more, right? Team is together everyone achieves more. So when you want to work in a new domain like machine learning, you try to join hands with your friends, your colleagues, or your seniors, or with your research students, right? And let it be a kind of synergetic attempt to learn more about the new technology and try to understand how we can use it for your research work. Okay. So base decisions on data, not opinions. So this is how the machine learning model is going to work, and that is the reason why it is able to give better accuracy than human computation, because the decision that is taken by machine learning model is only on data and not on opinions or perception. So improvement opportunities are endless, right? Keep moving. So probably this FDP may open up new doors of opportunities that really lies in each one of your hands, like how best you are going to capitalize this opportunity. So from the influencer, as we talk about this artificial intelligence, now this is the verse of Jeff Bezos, who is the Amazon CEO. He says, now whatever that we witness, right, as the development or advancement of artificial intelligence is negligible, right? And what is in store for us in the future is much, much more than what we are perceiving now or what we are witnessing now. So his words are, we are at the beginning of a golden age of AI, artificial intelligence. Recent advancements have already led to invention that previously lived in the realm of science fiction. And we have only scratched the surface of what's possible. So this is a kind of opportunity for us, as we have scratched only the surface of artificial intelligence. Is it not our moral responsibility and binding as a faculty, as a researcher, to get into the core opportunities of artificial intelligence and then try to explore the opportunity? It becomes a kind of success for every one of us. So this is John McCarthy. I think you all must be aware of this great personality, and he is known as father of artificial intelligence. John McCarthy was one of the founders of the discipline of artificial intelligence, and he coined the term artificial intelligence developed, and he is the one who is responsible for the development of the programming language Lisp. Those who got graduated in computer science between say late 90s and early at least up to 1995, you must be aware of Lisp, Algol, because we used all those programming languages for developing decision systems. So develop the Lisp programming language family significantly influenced the design of Algol programming language, and he is the one who popularized the idea of time-sharing compute. So his role was highly, highly influential in the early development of artificial intelligence. Why? And he is the one who got an idea, why not we can make machines to think like a human being, for which he organized a workshop or a kind of brainstorming session on how to formulate the theories, principles, and practices of artificial intelligence. So while writing the proposal to seek funding for his workshop, he coined this terminology, artificial intelligence. So that has taken us this far. So now as we look into the definitions of artificial intelligence, a branch of computer science that deals with the simulation of intelligent behavior in computers, and it is the capability of machines to imitate intelligent human behavior. So just let us not get into any kind of complicated definition, or it is just sufficient if you have what is meant by artificial intelligence. Now, this is a sheer practice of making a machine to take decisions like a human being based upon different models. So what do you mean by the model? They are just algorithms. They are just a set of instructions that can make decisions based on the data that you give for training. This is too early to talk about training. I'm just making a mention about how your brain, my brain, is getting trained on the experiences, the learnings that takes place around us, right? In the similar way, the machines are going to get trained or exposed to the training procedure, and that is going to enable a machine to behave and think like a human being. So the theory and development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. Here you have to take a grasp of all these things. So how do you measure or gauge human intelligence? It is based upon your intelligence anchors on what is your visual perception. On looking at something, how do you recognize it? How do you make perception? Whether your perception is right or wrong. So based upon visual perception, by using the brain's intelligence, we are able to exhibit visual perception, and we are able to work on speech recognition. Now, there can be a common medium of communication. Then we converse in the common medium of communication, and that is going to be translated, probably depending upon your mother tongue. It's going to get translated to your mother tongue, and then the understanding, the inference, the analysis, everything takes place. So for excuse me, for speech recognition, we need human intelligence. Then for decision making, what is decision making? Now, depending upon my knowledge about something, depending upon my experience on something, depending upon my expertise on a particular domain, I make decisions. I do something. And then it is like translation between languages. Suppose if your translation between language is very vibrant, then your language skill is good enough. So these are the areas which are highly necessary, or which are being done by the application of intelligence governed by human brain. So all these activities, visual perception, speech recognition, decision making, language translation, then doing some analysis on a language content, then doing some inferences, all these things can be done by a machine with the support of artificial intelligence. I will just make you to understand what is the core idea of artificial intelligence. Let us go by the words of Tom Mitchell on machine learning operational definition. See, now we just talk about what is the concept about, right? What is the theory behind that? So this is all about the operational definition of machine learning, and it is equally applicable for artificial intelligence as well, because artificial intelligence is a broader umbrella that encompasses machine learning as well as deep learning. Now, before we get into this classical definition, now suppose if you are interested, or if I'm interested to learn piano, right? What do? I have to first of all get training on working on piano. I have to understand the musical notes. Then I have to put them into practice. I have to understand how these keys are to be operated. So the foremost thing that is required is understanding the problem for which I have to get trained, right? So training takes place. So when the training is going on, my master, after probably 3 months time, he or she may like to evaluate what is my learning about, how far I have learned, is it good enough or not. So when I have to be evaluated, they are going to use some metrics based on which they evaluate whether my learning is good or not, whether my learning is prospective or not, whether my learning is on the right track or not. So there is going to be a performance measure, right? That will make the evaluator to check whether I'm doing it right or not. So there is a task, let us call the task as T. Task is playing piano, and that skill can be measured in terms of my performance, right? And that is going to be evaluated. Now, when do I say my learning skill is good? When do I say I'm learning in the right way? Due to my training, when the performance is going to get increased over a period of time, right? If I can show better performance, if my performance is X, then my performance after 1 month should be X plus. Then my performance after 2 months should be X plus plus. So now the performance has to gradually exponentially increase. If this is there, if this component is assured in the entire process of learning piano, then we can say that my brain is helping me to learn and then understand and acquire the skill. Okay. Now the same principle is going to be applied to a computer program that we are going to call as a model. So a computer program is said to learn from experience E. So what is experience? By practicing again and again and again. Experience comes through training. So learn experience E. So the experience that you get in doing a task, it can be driving a car, it can be singing, or it can be learning a programming language, or it can be just writing a comprehensive note, whatever it is. And from experience E with respect to some class of task. Task can be anything. You can imagine any kind of task for T. And the performance measure is P. To measure the performance of my task, I just make it as P. If its performance at task in T is measured by P, that improves with the experience E, right? And Tom Michel has given this as the operational definition, and you can just read this once, and one of you can let me know whether it makes any sense for you. Okay. So hope I just understand you have gone through this definition and you are able to infer the core or crux of this definition. Okay. I'll just come again before I move on to the next slide. So a computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance at task in T as measured by P improves its experience. So this is all about, once you are clear about this definition, we don't have to worry much about what artificial intelligence is all about. So now, what is so great about artificial intelligence? It is responsive, right? Whatever be the question that you're going to ask to a teller, to a chat box, it is able to converse back. It is responsive, it is decisive, it is adaptive, and it is independent. So AI can engage in interactions from humans and other machines, interpreting meaning and formulating an appropriate response. AI can interpret supplied information and take appropriate actions to achieve its mandated goal. AI can internationalize new information and adjust its behavior according to maximize its effectiveness. It becomes adaptive, right? And suppose if you are going to develop a model for the detection of spam emails, right? And you might have developed a model to identify spam emails with the respective criteria. But as it is working on different types of spam emails, it just learns by itself. It just gets into incremental learning. It learns by itself, so it becomes adaptive. Then it is independent, right? And like human being, on many times we may be dependent, but at any point of time, at given any situation, machines are independent. So AI can conduct most of its decision-making process without the need of human input or human intervention. So you all must be knowing about the breakthroughs in artificial intelligence that has made the world to get revolutionized about the advanced technology. The first one is IBM Deep Blue, that is we call this as the first supercomputer, which is designed to play chess with Gary Kasparov. And to the surprise of the entire world, this machine was able to win over Gary Kasparov in few matches. And then this is humanoid Sophia, and who has got the first citizenship. The machine has got first citizenship from Saudi Arabia. And you must have seen videos how this machine is responding on many occasions better than human being. And then this is IBM Project Debater. This is again another supercomputer which was designed to debate on a particular topic for and against. And it was able to take up a debate with world best debaters. And to the surprise, it was able to perform well. But unlike this IBM Deep Blue, the performance of Project Debater was not very impressive, but still that has given a lot of leads to improve on its performance in the necessary directions. So the growth of artificial intelligence between 50s and 70s, right? People were working with neural network for making decisions. So early work with neural networks is the excitement for thinking machines. Then between 1980 and 2010, people start working on machine learning, right? And there are a lot of models which were available at that time, and that really gave them a good amount of hope to use this machine learning model for decision making, for classification, for prediction, and many such operations that really require human intelligence. Then now we are in the era of deep learning, where the advancements which are made on this neural network has made the machine to have a deep learning about the problem that is given. So when the understanding is better, when the learning is improved, naturally the results are going to be better. So this machine learning introduction, we can just look here, this cartoon. Human says, I can learn everything automatically from experiences. Can you learn? And the machine says, yes, I can also learn from past data with the help of machine learning, right? So machine has started learning, and now it is going to compete with the brain of the humans, right? So the essentials or basic things that we have to know about machine learning. When you want to master machine learning, it is highly important to grasp the basics of statistical, probabilistic, and optimization techniques. Right? Just we have to brush our brain on the basics. Then algorithms that can learn from observational data. What is meant by observational data? The past data is being called as observational data and can make predictions based on it. Suppose if you want to develop a model for weather forecasting, necessarily you have to work on observational data or past data or historical data. And that data will give us an idea about if the weather conditions with these parameters, humidity, then sunshine, and then whether it is going to be rainy or not, and what is the temperature of the day, and what is the kind of wind velocity of the day. Suppose if we have all those things, they are going to conclude with respect to the weather condition. So any kind of model that we develop necessarily needs some kind of observational data. Observational data are the one which were observed in the past, and they are going to become a source for training the models and can make predictions based on it, and explicitly used to make decisions based on the learned patterns and create any analytical model for future predictions. So when we were in our kindergarten, we were taught the alphabets A, B, C, D. We just learned only from the pattern how A should be. We just used our visual perception. So there should be two static lines. There should be one horizontal line to make A. So then B, C, like this, there was a pattern to understand. Then we were taught about how best we can combine the alphabets to form a single word, then two word, then sentence, then paragraphs, then essay. It just goes like that. So there is going to be a pattern which you can see when you learn something new, and that is going to help human brain to understand the entire process. In the similar way, when you get the observational data, let us take the topical example, COVID-19. So when I'm going to have the patient's data with respect to say name of, the patient ID, then the age, gender, then the different kind of symptoms which are present, right? Just please hold on. So sorry for the interruption. So when you have a set of parameters, or we call them as attributes, like what is the temperature of a person, whether the person is having a running nose, continued cough, or nasal congestion, like breathlessness, tastelessness. So these are the features which will decide a doctor, which will facilitate a doctor to decide on whether the person is having COVID-19 symptoms or not. And that is endorsed with a kind of any kind of scan that they do on the chest.
Ma'am, is there any issue, ma'am? Ma'am, your voice is not audible. Yeah, she'll be once again joining. She has some network issue there due to some power loss. Yeah, ma'am's system got stuck and she's restarting the whole system. She just informed and she'll be joining in 2 minutes. Please bear. Okay. Meanwhile, as you know that you need to write a test on the last day, and the test is scheduled on the last day evening after the validity function. From 4:45 to p.m. we keep the link open, and you'll be given a Google form where you can through which you can take the test, and roughly there will be around 50 questions, and all multiple choice questions will be there. And I request all of you to, unless and until you write the test and get 50% of the marks, you will not be getting the certificate. So please keep that in mind, and please write the test in order to get the certificate. Do you have any other queries related to the test and other things?
Hello, good afternoon again. I'm extremely sorry for the delay. It got stuck. There was some technical issue in my machine. So I think I should be given the option to share the screen.
I'm doing that, ma'am.
Yes.
Yes, ma'am. Now you are a co-host.
Yes, yes. And now it is enabled now. இல்லையா ஓபன் பண்ணியாச்சு போயிடுச்சு போல. I trust it is visible to you all.
Yes, ma'am.
Okay. So please let me know from where it got interrupted. Is it here or in the slide? Hello?
Yeah, next slide. You are almost done, and that time
Okay.
it was.
Okay, this is the one?
Yeah.
Okay, right. So thank you. I'm very sorry for the delay because there was networking as well as system error. That's fine. Expect the unexpected. Okay. So what I was telling about this slide was anyone who wants to excel in machine learning should know the basics of statistical, probabilistic, and optimization techniques, because all the methods, machine learning methods, and then any kind of model that you want to explore in the light of machine learning anchors on statistical probability or statistical principles, probability principles, or optimization. So any one of us should essentially have hands-on details about statistical probability as well as optimization. Then I was making a mention about the observational data. And what is meant by observational data? I just asked a question what is meant by observational data? Any past data is being called as observational data. And it is essentially important for us to have a good collection of observational data, because we can understand the pattern of any given data only when you have the entire collections from the past. I just quoted an example. If it is weather forecasting, we do the forecasting only based on the past data. And if it is disease identification, we should know the pattern. Suppose if these elements are present, should I conclude that the disease is present? If these elements are absent, should I conclude that the disease is absent? Suppose if you look out for when you go for paper valuation, you just see if these points are present, then the student has answered the question. If these points are missing, the student has not answered. So when you want to make a decision about something, we always look for certain patterns. So these patterns are the one which really help us to understand the baseline or the baseline statement of any given problem. So as we understand, suppose if you're asked to solve some logical reasoning, you try to read the statement, understand what are the points given, what is expected. In the similar way, is it going well? I just want the confirmation. Is it audible to everyone?
Yes, ma'am.
Okay, thank you, sir.
Yes, ma'am.
Okay, so we make decisions based upon the learned patterns. What is learned patterns, which is already known to us based upon our experience, and create an analytical model for future prediction. If it is for COVID-19 positive or negative classification, it is going to be done only with respect to the knowledge the doctor has learned or the knowledge the doctor has acquired on the identification of disease. So it is important for a doctor to have good knowledge about the disease, how he or she does it, and they should look into the parameters, health parameters of a patient. So what is the age, what is the gender, then what are the symptoms that are available, that is the temperature, whether it is very high or moderate, and whether the person is having cold, common cold, or does he or she have cough also, nasal, kind of breathlessness, then tastelessness, then congestion. So all these things are deemed as typical symptoms of COVID-19. So if a patient is having all these things, the doctor has to suspect whether the patient may be positive or negative. So the same kind of activity is going to be done by the model that we develop for COVID-19 identification. So explicitly used to make decisions based on the learned patterns and create an analytical model for future predictions. So you have to understand here what is meant by the pattern. And in the case of weather forecasting, if these parameters are present, then it is going to be windy. If these parameters are present, the day is going to be very hot, shiny. And if these parameters are there, it is going to be rainy. So we make conclusions. How do we make conclusions? Based upon the previous data. And what do we do with the data? We explore the data, identify the commonality in the data. That will help us to come to a conclusion about the given set of data. So explicitly used to make decisions based on the learned patterns and create an analytical model for future prediction. So then this is the kind of workflow, and we should start with data, and then of course the data handling involves data cleaning, and then we have to go for data imputation. Let me not go into the details of that. Let us assume you have data intact in your hand. Then in the given data, we have to explore patterns or features, right? And these features are going to be used by the model for training the model. So model training takes place. Then once the training is complete, we have to evaluate the performance of the model. And then based upon our conclusion, we are going to look into the output. So the accuracy of classification is highly influenced by the distribution and diversity. Yes?
The slide is not changed.
I have not changed, sir. I'm still talking on the slide.
Okay, okay, I'm sorry.
Yes, sir. No issue. Thank you. So we are going to, the accuracy of classification is highly influenced by the distribution and diversity of data. So why do we have to focus on this? Now, you must be knowing about any data should follow normal distribution, only then you can use it for a proper processing. Because if I'm going to develop a general model for COVID-19 identification, then my data set should contain a good equal number of positive as well as negative, right? And the good representation of children, then youth, then adults, then middle-aged people, old-age people, very old-age people. So only when I have these kind of combinations, the model will be able to understand what could be the symptom, what could be the different kinds of symptoms that are prevailing in the patients. So, and we have to ensure the data is highly distributed and diversified. So why we have to think about this machine learning model? Because number one, sometimes in an environment, in a situation where we don't want to deploy a human being, in such situations, this machine learning model is a great advantage, or it is a great boon to us. So industrial manufacturing control, if you can just think of a nuclear power plant, so it is better to have a model instead of just deploying a person, which is not feasible. Then any kind of analysis, data analysis, it can be mass spectrometer analysis, drug design, then astronomical discovery, and the list is countless. Then black box human expertise, as we were discussing, you can just think of face recognition, handwriting recognition, speech recognition, and all those things, right? Then it is like driving a car, that also involves. And can any one of you explain to me about how a car can be driven? How do you learn the art of driving a car? Or can you just give a scientific explanation about how you can, how you have learned the art of writing? Can you just, just put it in the form of typical statements? Because the intelligence, how it is acquired, how it is applied, is beyond the explanation. So that kind of principle is going to be deployed in the model about face and handwriting, speech recognition, driving a car, and flying a machine. So all these activities, now we talk about automotive vehicles, automobiles, then even flying a machine can be automated with the support of artificial intelligence, face recognition, handwriting recognition, image identification, image detection, face identification, face recognition, then occluded face recognition, identifying the handwriting, then classifying the handwriting, recognizing when you talk to your mobile phone through the voice security, right? It just listens to your voice and then it recognizes, it just opens up. So speech recognition, all these things are typically being done by the machines, which were only done by human being earlier. Then rapidly changing goalposts. Now, we have gone to an era wherein there are a lot of things which were not required in the past have become mandate now. So credit scoring, there was no question about credit scoring earlier days, but now all the banks, they highly need information from this credit scoring component for any kind of customer when they want to issue a loan or a credit card or the ceiling for the credit card. Then financial modeling, if a company wants to decide about how to plan for the budget in terms of how much for operation, how much for capital, how much for investment, how much for other financial commitments, it has to have a financial model. So these kind of complicated requirements were not required earlier, but now because of the neck-to-neck competition, all these things have assumed a lot of importance. Then disease diagnosis, fraud detection in the case of sending email, or in banking sector, these kind of things weren't there, but now because of various online transactions, these kind of activities are to be curbed. The need for customization and personalization. And personalized newsreader, we are experiencing. Suppose if you're interested only in movies, it is possible. And if you're interested only in news reading, it is possible. If you're interested to read only, to watch a specific kind of movie, science fiction, or it is just a kind of sentiment movie, it is possible. There is a recommender system which sits and analyzes your profile based upon your activities in the internet, your age, your educational profile, then your interests, then your professional skill, all these things put together, right? They are able to identify what are your interests, and it is able to make recommendations. Okay, so now I'll just highlight the need for Python programming. Python is a popular platform that is used for research and development of production system. It is a vast language that has number of modules, packages, and libraries that provide multiple ways of achieving a task. Right, I request the head of the department to arrange for at least 2 days hands-on workshop where we can give end-to-end training on how to use Python programming from the scratch, because it is highly it highly, it may be relatively difficult for those who do not have any basic understanding about Python programming, just to grasp about how to use Python programming for machine learning, because it involves data migration, data handling, data cleansing, all those stuff. So it is a typical tool which can be used for machine learning programming. Python and its libraries like NumPy, Pandas, SciPy, Scikit-learn, and Matplotlib for visualization are used in data science and data analysis. They are also extensively used for creating scalable machine learning models. Then Python implements popular machine learning techniques such as classification, regression, recommendation, clustering. So this is the core aspect, that whenever you want to devise a solution for any problem, it will fall into any one of these categories of regression, classification, recommendation, or clustering. So Python offers ready-made framework for performing data mining tasks on large volumes of data effectively in a lesser amount of time with greater accuracy. So as we have discussed good number of applications of machine learning, I'll just try to comprehend healthcare services, language translation, fraud detection, especially with a special mention on online, then online customer support, online customer relationship, customer management, then email spam and malware filtering, social media services like face identification, similar pin in WhatsApp or any kind of a social media that you use, then virtual personal assistant. Now Siri sits and then talks to you, what can I do for you? So these are all the examples, like smart speakers, smartphones, mobile apps. So prediction while commuting, then you are traveling in a car, say in Bangalore, then if it is highly crowded, if your path is highly crowded, you can just look for an alternative of alternate road is less crowded, so that you'll be able to reach your destination without much difficulty. So traffic prediction, online transportation network, all those stuff. So I think I'm supposed to finish by 1:15. Within half an hour, I'll try to just focus on the types of machine learning models that we have. So now, as you look into any machine learning model, they are broadly classified into supervised, unsupervised, and reinforcement. So from the name, you can understand supervised means you give the question and then answer and then make a student to get trained. If the model is going to be given both input and output, the model understands if these are the inputs, this should be the output. So it is able to formulate a mapping function between the set of input parameters and the output parameters. So I think all of you must be knowing the output is known as class label, right? And if you have data with both input and output, right, it is called as annotated data, or it is the data that has the class value. So it is called as labeled data. So any supervised model requires, demands labeled data, and this unsupervised model doesn't require labeled data. You can just have a data, just input parameters. So just look into this visualization. Now you take known data, right? And what is known data? You have both input as well as output that is given to the model. Then the model, you know the output also, right? It is a known output. You know the model is going to understand if the shape of the image is going to be like this, then if this is going to be the texture, then it is mango. So the model recognizes this as the mango, right? The model is trained. Now you are going to give mango, that is, this is a new data. So these are called as observational data used for training, and this is the new data that is given to the model. So now we have to validate. I spoke about the performance, right? The model's performance is going to be measured, evaluated, how best the model is able to recognize mango as mango on many occasions. This is what you call as testing process. Then this is supervised learning. Then the next one is you just give the known data. As you have here, there is no output. So the model is trying to understand the similarity or a pattern or behavior between them, and then they are able to properly. Okay. So then in the case of unsupervised learning, 150. Here you can see here there's a model is present, then known data is given. This is going to be used for a kind of you can see here you have got mangoes, bananas, oranges, all those stuff. The model is going to do the classification. You can see here, no, apple, not orange, sorry. So mango, apple, and then you have got this bananas. Now what is being done based upon their structural similarity, based upon their texture similarity, based upon the color component. Now it is able to categorize them into 3 classes. That is one class for mangoes, one for apple, and one for banana. So this kind of classification is being done based upon the similarity measure and then their association between the similar objects. For this, we do not need any output because we are not validating, we are just doing clustering. So this is an example for unsupervised learning. What is reinforcement learning? Now you just give the model, right? You train the model and then we train the model and then you validate it. Sometimes the model may be accurate and sometimes the model may not be accurate. In such cases, what happens, whether it is accurate or not, that is given as a feedback to the model to understand. So what do we do after giving a test? We evaluate and then we come back to the class and then tell, so for this question, you should have given this answer, but your answer is different. So you're giving a feedback to the student how the answer should be. In the similar way, now after the model does the prediction, right, it is going to get a feedback, right, that is called as backward feedback. So it is back propagation. So it is given. Now the model understands. Suppose if it is correct, it is taken as an award. If it is wrong, if the prediction is wrong, it is taken as a penalty, based upon which the model is going to fine tune itself towards better accuracy and better performance. So now this is feedback is being done. Once it is done, once a reinforcement learning, why we call this as reinforcement learning? This is a kind of principle of learning in the light of psychology. Now, if a child is doing good, you just pat, give a chocolate, give a kiss, then the child understands I am doing this is what I will get. And because this model uses that policy, it's called as reinforcement learning. So once the training is done, then you take the input, the model is able to process, then you get the response. So the same thing, whatever we have discussed, right? Then unsupervised, supervised, you have got the training set. Then the model should extract the features. Then the machine learning algorithm does the training and then testing. Then the final result is being got. Suppose if this is about identifying the abnormality in the brain. So based upon the performance of the model, it may be categorized as a healthy brain or unhealthy brain. So now the result, I told about annotated data. If you have this image alone, it is just an image. And if you're going to categorize this, give a label, it is a good brain or a healthy brain or diseased brain, that is called as annotated data. Okay. So this is the same thing, and for want of time, let me just skip it. And the supervised learning, unsupervised learning. Now, this regression, I'm going to discuss about what are the 2 kinds of major operations that you do under machine learning. One is regression, finding the relationship between the input parameters and the output parameter. So that is called as regression. Classification is categorizing the items. So what do we do in the case of regression? That is mapping function is used for mapping values to a continuous output, right? We'll see examples for that. So what does it do? It does prediction, or it can work on one independent variable, one dependent variable, or multiple independent variable and one dependent variable. What is the nature? It is a kind of ordered approach. Then in the case of metrics that you use, you just measure with respect to what is the error that is incurred in identifying the right answer or right prediction. So algorithm is linear regression. So in the case of mapping function is used to map the values into the predicted classes. I think you all must be having some basic idea about decision tree. So you can just correlate with respect to this. The outputs are going to be discrete. If it is COVID-19 identification, it is positive or negative. It is not infinite. So discrete values, it works on unordered set of data. Because when you talk about this kind of regression, you have X component and Y component. So it goes like that. So discrete values then unordered by measuring the accuracy, decision tree, logistic regression. These are all typical examples for classification techniques, right? So linear regression, now we work on one independent parameter and one dependent parameter. So here, this kind of predictive modeling, that is why it is called as linear regression. We are going to fit a line between the independent and dependent to assess the relationship between input and the output. So it is a kind of predictive modeling where a possible output, please always remember, the output is going to be referred to as Y and the input is going to be called as X, right? Is predicted based upon the previous data or values. What is this previous data? Once it வரைக்கும் continue பண்ணிடுமா? அப்படியா? அப்படியா? Okay. Right. I'll just make a mention and then just go ahead. Okay. Right. I'll try to finish as early as possible. Okay. So this X and Y, and you must be knowing, I think it is already dealt with in one of the sessions. So we just fit the line. Now, what is the error? The points that are not lying on this line and the points which are just lying outside, that is being called as error, and that is being done. Okay. So linear regression, this must be the formula that you must have worked with. So what are we going to do? What the model will do? The model is going to develop a mathematical relationship between X and Y. It applies this formula. So Y should be predicted. It has the value. Because you have the line that is going to calculate what is going to be the intercept. I think this curve fitting is known, line fitting is known to every one of you. Y is equal to ax plus b. So here a is the slope and b is the constant. It applies it in each and every data point. It calculates, then generalizes it. Okay. So this is again about linear regression. Now, in order to measure the evaluation, we work with respect to error as well as cost factor. Now that is done with respect to what is the actual output and what is the predicted output. So the difference between them will make us understand about the performance of the model. So the next one is logistic regression. This works with appropriate regression analysis to conduct when the dependent variable has a binary solution, whether it belongs to this class or not, right? Now in such cases, there are different types of regression. One is binomial, the other one is multinomial, the third one is ordinal. So you have to take a decision. When should I use what kind of logistic regression? Let us go into this. Suppose if it is win or loss, right? And then pass or fail, yes or no. It is only two possible values. Because it is two, it is called as binomial logistic regression. And suppose if this is A or this is B or this is C, now it is one among many. In such cases, it is not ordered. It can appear in any form. And in such cases, it is called as multinomial regression. With respect to this category of, say, you have a scale, right? A 5-point scale or 4-point scale. It's very poor or good or very good. You have the scoring that is ordinal, arranged format. This deals with ordered category, and that kind of regression is called as ordinal regression. So understanding the influence of dependent variable on the outcome of the uh, independent versus a dependent. The demerits are, and it only works on predicted value when it is binary, right, between one among the given choices. So now you should just understand, if it is going to be a kind of logistic regression, there will be one curve called S curve, right? Now it can be in the form of S curve. When you apply gradient descent, it can be in the form of U curve. What you have to see here is, now in order to find the best solution, right, you have to find where the error is minimum or where the cost is minimum. So this is why I said you should be thorough with the optimization. So in such cases, we are going to just apply the optimization, and then if it is cost, it should be minimized, and if it is profit, it should be maximized, and accordingly, you have to just make a balance. Okay. So for this purpose, we use a sigmoid function. We call that as an activation function. What is an activation function? The activation function will transform the non-interpretable intermediate values into an interpretable value, which can appear in the form of some probability value, right? And that probability value will be used by the model to take decisions. So this is an example for sigmoid function. I'll share the PPT with you, so you'll be able to use it. So the second one is for classification. This is a decision tree. This decision tree is the one which has got a root node, and then it does the process of splitting. And I think most of you must be familiar with decision tree. All that we have to understand here is, now you have a very simple Python code for implementation of decision tree. So you have to understand, if you have multiple attributes in your hand, then suppose if it is 5, then I can use all the 5. If it is going to be 50, when I construct a decision tree with all the 50 attributes, it may be very complicated. In such cases, what am I going to do? I am going to handpick the essential and most important parameters. How am I going to do that? That is done with respect to entropy information gain. So these are the parameters which will make a programmer to understand the significance of all these parameters in terms of the information each and every parameter depicts, as well as how it is going to be used for decision making. So at any point there is splitting, right? That is, you have to carry, I mean, just branch out. So how it is going to be very helpful in effective branching? I'll just give an example. In the case of COVID-19 identification, if I have, say, patient ID, right? So patient ID is not really going to help me at all. It is only a number. So what is the point in using that as a parameter in decision making? So you have to handpick the essential features which will help us to understand about the entire process of classification in the best possible way. So this is how we have to arrange, and we have to start with the root node. All the class labels or the output will be available as the terminal node right here. So you have to start from the root node, keep branching out till you reach the terminal. This becomes your choice. So this example, I made a mention about entropy and information gain. If the data is given, then you can formulate a decision tree, and you can go from here, branch out and reach yes or no, whether a child can go out for playing or not. So here, 1, 2, 3, 4, 5. The first 5 attributes are input parameters. And then this is the last one is the output parameter. So we target about this output parameter when you go for prediction. Okay, I'll just leave the merits and demerits. I can just make you see after I share this PPT with you. Then this is about support vector machine. Now, why it is called a support vector machine? Because it is going to work on the vector points. Now, suppose if there is a classification of, a spread of data points like this, the model is going to draw a line in between, right? This is called as maximum margin, or this is being called as the line that we are looking at, line that can separate two sets of groups away from each other. So you can call this as a hyperplane. This is called as hyperplane. Now on either side of the hyperplane, we are going to draw a line, a dotted line, right, which is going to be called as negative hyperplane. So this negative hyperplane and positive hyperplane, what is the significance of these 2 points? Now you are going to draw a line, an imaginary line, right, which will make maximum distance between the maximum hyperplane, and then this is called a support vector. Support vector is the one, because this support line is being drawn on one vector point, that will make us understand there is a perfect classification between the data points. So we call this dotted line as a support vector. The space between this hyperplane and the support vector is called as negative hyperplane, and this is called as positive hyperplane. Right? So, so what is the purpose of this? You are going to separate them because you use machine learning. The support vector machine learning algorithm on most of the occasions for classification. Of course, this is ideally suitable for regression also. So the model is going to choose this optimal hyperplane, and then it chooses the support vector in such a way that there is no overlapping between these points. Hence, it is called as support vector machine. Now, as we look into the types of support vector machine, then it can be classified into linear separable data points. SVM for linearly separable data points, and then SVM for non-linearly separable data points. So by looking into this, you can understand, suppose if I have the data points spread across my problem space this way, I can just draw a straight line and separate. If the spread is going to be this way, then it is highly not possible for me. It is not feasible, viable for me. Just draw a line and separate. So what are we going to do when you have this kind of problem? SVM has a solution for this. Now, when you have non-separable point, then you have to augment the space. If it is one-dimensional data point, you have to upgrade it to two-dimensional data point. If it is two-dimensional, you have to upgrade it to three-dimensional data point. So by doing that, you will be able to separate them, right? So now it is going to, as you have the cost function and error function for regression, now this SVM is going to use a function called Hing loss function, that will make us understand by the selection of these points, right? This hyperplane and then the support vector, what will be my loss? What is loss? If the points are not getting properly separated, it is a loss. So that is being computed. So it just does by means of this function, the c comma x comma y f of x. What is f of x? The relation between input and the output. So this is going to be 0 if this function is, this condition is satisfied. Y is the output multiplied with f of x. That is a functional model between input parameters and the output parameters. If it is greater than or equal to 1, right, then it is 0. Otherwise, this is used 1 minus y into f of x. This is taken as the cost. Okay, so this again another approach. So this will make you understand how to handle the non-linearly separable data points. This is one-dimensional representation. Now by converting it from 1D to 2D, now this becomes separable. Then another example. So this is two-dimensional. Now in this two-dimensional space, now I just change it into three-dimensional. Now this is linearly separable by means of this hyperplane. The hyperplane is able to separate. So what is that you have to understand now? If you have a data set which is not linearly separable, and if you have a data point which can be upgraded to the next level of its space representation, then you have to explore the choice of kernel that will help us to handle these kind of issues. And those who are, because SVM is a very, very powerful model. So you have to see what is the role of kernel and what are the different types of kernels available, how you can make use of it. I just skip the applications because across all the models, the application is almost the same. Then this is yet another model, naive-Bayes classifier. Now this has got a lot of impact in the case of classification as well as regression. Now this works on the principle of Bayesian principle or Bayesian probability. So now suppose if you just talk about one event, when you just throw a die, right? If you just toss a coin, then it is getting head or tail is decided by the way in which you toss the coin. So it probability is 50-50. Now, suppose if I'm going to toss a coin, right, and if there is another coin, right, which is also going to be tossed. Now, if the combination of head and head, tail and tail, or head or tail is going to be decided dependent on each other. In such cases, when there is a dependency between the events, in the case, I mean, in the sense that when we have multiple attributes, when two attributes are dependent on each other, in such cases, we have to identify what is the probability of one event that occurs influences the occurrence of another event. So that is explained by means of Bayes theorem. It's about conditional probability. So it is P of A given B is given by P of B given A multiplied with probability of A divided by probability of B. So now we just deal with this with respect to this is taken as probability of C given X is taken as posterior probability, that is which has already occurred. Now we just take a note that this is the one that you want to predict, right? This is the one to be predicted. This prediction is going to be done with respect to the previously occurred instances. So this is called as posterior probability. We have to calculate posterior probability, and that learning will make us to predict this new probability. So this is likelihood is that may occur or may not occur. This is the one that we are looking for. So posterior probability is equal to P of X given C, and then P of C, we call this as prior probability, and P of X, we call this as predictor prior probability, right? So class prior probability is the one that we already sure about. So predictor prior probability is that has happened with respect to the association between two variables which influence each other, right? So I would request you all to get into the details of the statistics and how do you understand between a simple probability and conditional probability, and how do you view this with respect to influence of one over the other, how to compute. I would just request you to just get the basics of all these things. Okay, so far we were learning about supervised learning, and this is about unsupervised learning. You remember we had a diagram where apples, bananas, and mangoes were there. We got classified. So here, this K nearest neighborhood is a typical approach that you can choose for unsupervised learning. Now, sometimes when we talk about the supervised learning models like SPM and then naive-Bayes classifier or even decision tree, in such cases, each and every model by its own functionality, we can classify them into lazy learner and eager learner. So you understand and you must be having clear idea that a model has to undergo a training phase as well as testing phase. So this training and testing phase should be exclusive, like mutually independent. Now, suppose if the model is going to acquire the entire knowledge about doing a task during the training phase, it is called as eager learner. And suppose if the model is going to postpone the process of training till it is going to go for prediction, that is called as lazy learner. So this K nearest neighbor is a typical example for lazy learner. And here I have just given what is the need for parametric and how do you distinguish between parametric machine learning algorithm and non-parametric, right? And this is all about, suppose if you have a smaller data, then you can use simpler model. If you have very large data, which has to require, I mean, a complex potential in problem solving, accordingly, you have to go ahead. Okay. So I think I don't have to go into the details of the algorithm of K nearest neighbor, and I'll just highlight the essentials of K nearest neighborhood. So what do? We specify a value called K to the model K nearest neighborhood. So this K is an odd number if the number of classes are 2. So this is the condition that we have to follow. Now let us see here. There are two classes of data, one with red colored stars, and here it is green colored triangles, solid triangles. So now in this case, I have to classify whether it is going to be class A or class B. Class A is red color, class B is green color. So by looking into the feature, I am going to decide whether I have to push it this side or this side. So what do? For this, the KNN will identify the data point to be classified. Then it just contacts the nearest neighbors by calculating Euclidean distance or Manhattan distance and other kind of distances available. So by looking into the nearest points which are nearby, which are lying very close proximity, it just looks into the features and then trying to see, depending upon the similarity between this point, the point in process, we call in process point, or the data point under process, and the remaining nearby points, it is able to find the similarity. Depending upon the maximum similarity and the nearest distance, it is going to be classified. So these are about the merits and demerits. I just skip it for want of time. Now here you have to learn about the ensemble method. Once you are very thorough and confident about all the models, right, you can just explore the possibility of going for ensemble. What is ensemble? We are going to have a combination of models. So there are two types of approaches in this. One is bagging, other one is boosting. So what is bagging and boosting? Now there is a choice in front of you. One is you just use the same model multiple number of times and try to get the best result out of it. Another method is I'm going to use decision tree, I'm going to use logistic regression, I'm going to use SPM, and then combine the potential. So these are the two approaches. So we just explain them by means of bagging and boosting. So bagging is a method of merging the same type of predictions. If it is by decision tree, we just go for random forest. And boosting is a method of merging different types of predictions. One can be from one method. I can combine 3 different methods and then do it. So the caution to be taken by us is the bagging decreases variance, not bias, and solves overfitting issues in a model. So I'll come to this overfitting very shortly. So boosting decreases bias, not variance. So you have to strike a balance between these combinations. So as you go for ensemble, it can be bagging, it can be boosting. So example is a random forest. Here it is gradient boosting. And I have given these points which are dealt here itself. Now that decreases variance and not bias, all this stuff. Okay. So random forest is the one we just go for multiple generation of multiple trees like this. Then we try to see which is the best one. Then we try to combine all those decision trees together, and then you go for the final prediction or final classification. So tree 1, tree 2 up to tree n. So you try to get the best values out of this, then you combine the potential and then go for the final model. So this is all about random forest. I have given an example, right? Tree 1, tree 2, tree 3. So this is going to give the best result as class A. That is, this works well on class A. This works well on class B. This works on well on class B. So now I can combine 2 and 3, right? So that I'll be able to check. I mean, you can put it this way, for instance. Suppose if I'm going to, I have a bunch of fruits here, out of which I have taken one data point, right? So now this is going to classify, say, an apple as apple, and this is going to classify an apple as apple, and this is going to classify apple as banana. So the tree is not working well. So what is the maximum vote here? 1, 1. That is 1 plus 1, it is 2. So two models have classified it as apple, so it is taken as an apple. And suppose if it is going to be, it happens to be an apple, but this also classified this as banana, and now the majority is banana, but still the answer is no, it is taken as an error. Right? So you have to understand how we are using this. Random forest has got a lot of scope if you want to use it, right? If you are comfortable with the decision tree, then you can go for random forest. It again finds application in all possible domains. That is without any exception. So now as we talk about, I'll just take 5 more minutes and then finish. So training and validation, testing, holdout data set. Now, when you try to go for the the splitting of data, right, then probably you should be very sure about how am I split between the data as training, validation, and holdout. So normally it is between 16. It is between 60 to 80 can be used for training, then 15 to 25 can be used for validation, then testing is between 50 and 25. But please remember, to decide about these figures, these values, you have to do trial and error. That will give you the best result. So tips like when you work with this machine learning models, so learn the tools and their availability and then their applicability, then learn the code algorithms for research, then selection of appropriate model, because each model need not give the best result for a set of data. So you have to handpick the appropriate model, understand the probability and data statistic values that are going to be used by the model. So then you should have thorough understanding about data management, data cleaning, then data imputation, and how to take data from the trusted resource, even if the trusted resource data happens to be not intact, and you have to know how to clean it. And then you should understand the value of data life cycle. And once the life cycle of data is done, right, there is no point in using it because it is going to be highly inappropriate. So understand the new use cases. When you have a problem, what are the new use cases you can have? For instance, if it is spam email, and if suppose if I have 10 points to categorize spam email, so later after 5 days or 5 weeks, I can have 5 more points uh, to decide about the quality of a mail as spam or good one. So it should be adaptive. I must be able to use it. So this is very important when you're testing. I mean, when you finish with developing a model, and you can classify them as either as underfit or overfit or good fit. So what is good fit? I'll just start with good fit. So it is able to classify these two classes with a minimum error, right? I mean, if you see here, this bubble is lying here and this into mark is lying here. But as you take this one, it is highly inadequate. It is not able to give any information about the splitting. So this is called as underfit model. And as you see here, it's a perfect classification. It is 100% classification, no misclassification at all. So when you have like this, like you have to understand that the model has not got trained. It has understood if these are the values, this should be the result. It learns the data, not the pattern. It learns the data. Suppose by heart, you can say 4 plus 5 is equal to 10. You don't apply any logic. By training, you have got. So if the model understands data by data and its output, it leads to overfitting, right? So now, as we talk about this model complexity and error, and this is underfitting, this is overfitting, this is the best fit. So that can be identified by means of the what is the test error, what is the training error, and based upon plotting a graph, you can do it. But normally, when you go for research, and we do not incorporate all these things in our research article. Now, by talking about the bias variance, what is the testing error, what is the training error, and how we can plot how the best model is being fit, if that is spelled in your paper, that will be a value addition. So here I have given what is bias. It is a difference between the model's average prediction as well as its corresponding expected value. The variance is the variability of the model in case if different training data is being used because it is not able to come to a conclusion. Okay. So characteristics: underfitting, low training accuracy, inability to solve complex problem. It is overfitting model if it is having high variance, overfitting, low testing accuracy, then overcomplicating the simpler problem. So the same thing is represented here. From this you can understand, right, what is bias, very prejudiced about certain things. So all the points, this is the goalpost where we have to reach, but everyone, all the points have got clustered but at the wrong place. So this is an example for bias. In the case of variance, and each one is at a different point, they are not able to converge. So there is a problem of convergence to getting a solution. This is the problem. And now you can, I think these things are dealt already, how you can calculate the accuracy. And normally we go by this confusion matrix, which has got actual classes plotted one side and predicted class values on other side. So now by positive, 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 negative, negative, positive, negative, negative, we try to get sensitivity, specificity, accuracy, then negative value, precision, etc. Please try to understand. When you work on this, you should have a very clear idea about when you have to call it as true positive, true negative, false positive, false negative, and accordingly you can just go for it. So then about the libraries and packages, like you can use NumPy, Pandas, then Matplotlib, Kit, as well as Seaborn. Seaborn is a very good tool for data visualization. Now, I assure that I can just pass some code for each and every model so that you can have a simple hands-on, right? I'll just pass it to the organizing, to Dr. Chandramouli sir. You can just go ahead with that. So 6-step process for machine learning. Get the basic understanding about the algorithm. That is very, very important. Unless you have thorough knowledge, please don't go into it. So get basic understanding about the algorithm, then find some different learning sources, then break the algorithm into chunks and then learn. Start with a very simple example, then you can move on to complicated data set, then validate the trusted implementation, then develop the process. So the same thing, right? Step 1, gather data, then clean data, model building, then gaining insight into the model's result, how it works, then you visualize and then finalize and then deploy it. So I have given the details of this data collection, data preparation, choosing a model train in detail. So you can just find when you are free, and after you complete, probably if you sit down and then try to see how best I can use the model, now we can just go through these parameters. Like the most important thing I just want to make a mention about before I conclude, this parameter tuning. Now, when you work with data set, I told about features, that is about the attributes of the data. When you take any kind of model, linear or logistic or decision tree or support vector machine or name-based classifier, and that model will have its own set of parameters that you call as hyperparameters. So the set of parameters that you use for tuning, right? This step refers to hyperparameter. This occupies a very important point. A word of caution now. Now we get inspired by this machine learning models, and we just apply it for problem solving. And if you're going to, because everything is ready-made, it is ready-made available. And if you're going to work only on the model, that will not give you any credentials. There will not be any novelty. So you have to focus on fine-tuning by working on this hyperparameter fine-tuning. Number 2, you have to use some optimization technique, and then you must be able to show some novelty in the model design. Only then that will be accepted as a novel and new contribution in as far as this machine learning is concerned. So the faculty members who are interested in can use your PG students to explore and then try to understand the model. After that, you can extrapolate it with respect to your problem by giving this as a big problem for the researchers. So I'm sorry that I exceeded my limit by 5 to 10 minutes. So if there is any question, you can just email me. And if you have any some kind of clarity needed when you want to work with machine learning, this is my mail ID and this is my contact number. And at any point of time, you can just shoot me an email or call me after 8 o'clock, and I'll be available. I may help you to validate your ideas and then how you can approach a problem. And I just give an assurance that I will share with you the Python code for each and every model, and you can have hands-on on your own because it is very simple child's play. So don't carry your mistakes around you and around when you're moving ahead. Instead, place them under your feet and use them as the stepping stone to rise above them. So all the best to you. And congratulations to the department, and special congratulations to head of the department and the organizing committee, which strengthens the hand of Professor Dr. Chandramouli. And I thank all the participants for your patient listening and your participation in this. I thank every one of you.
Is there any queries for ma'am? I repeat, do you have any queries? Only you are getting appreciations in the chat box, ma'am. Yeah. So thank you very much, ma'am. You have given the right point, saying that the novelty cannot be claimed by just implementing the models. That is very important. Take-home note for each and every one of us, that by simply applying model on some data set, no one can claim the novelty. That you should work further on how to optimize or how to tune those parameters so that you can improve the results. Very valid point you have shared, ma'am. And another great thing, you have given a mobile number. Really great. Most of the people may not give their mobile number. They just give the email and ask them to send the email, but really great. And also the finishing slide, valid, great saying of the thing. And with this, I really once again thank you, ma'am, for your complete coverage of the classifiers in a nutshell. Despite you had some hiccups in between, still you could able to finish your PPT with no skipping of any slide, but rather exposing each and the content in every slide to the best possible extent. Thank you once again, ma'am.
Thank you. I wish every one of you to reach the heights of your excellence in academics as well as research. And CUTN has got a lot of potentials to progress further in research and academics, and it is in the hands of the right person. I am just looking forward to see the progress. Right, good luck to you all. And because this is this Python programming and machine learning itself requires at least 1 week to just explore the nuances, because we have to start from the scratch and then we should start building the knowledge and learning. But still, this will give a kind of, this will really invoke interest about machine learning. So what we have done is the best thing possible. Now, after attending the FDP, I request those who are interested to pursue your research in machine learning, please do register for a complete course, right? And they will give you hands-on, and they will give you understanding about how to apply it for a problem, right? And because I'm interested in data science, I have registered myself for MTech data science, because it's wonderful when you hear from the experts. So there is no other goal other than learning a new concept by ourselves. So any kind of teaching can give you inputs about the entire thing, but it's important that we should be taking self-initiative to really master the subject. So please, I mean, go for online courses, then read the blogs and explore the YouTube's available videos available, and then you take a deep dive into these kind of models. And then, right, once you are very clear about the mechanics, the principles, the practices, right, then you have to start developing a new model of your own. Only then you can just seek the possibility of submitting it and getting it accepted in all IEEE or SCI or Scopus Index. Otherwise, it will be taken as a very primitive work. So you should not be miscarried by the way that if I just work on the model and the data set, it will not be considered as a novel contribution. Right? So this is just a word of caution. So thank you, sir, for this beautiful connect. And thank you.
Thank you, ma'am. Let us break for the lunch, and we'll start the next session by 2:15 itself, rather than 2:30, so that you can get more time. So with this short point to note, we'll break, and just remember that we start the next session by 2:15 itself. Yeah. Thank you, and thank you, ma'am, once again. And
thank you very much. Pleasure is mine as well. Thank you. Yeah. Bye-bye.